we are given a non-empty array of integers called nums, where every element appears twice except for one. Our goal is to find that single number and return it. In addition, our solution must also run in O of n time and O of 1 space. So let's say this is the array that we are given. The most obvious solution would be to use a hash table to keep track of the frequency of each number. So for example, we would start at the first element, which is a 4. So then 4 would be the key in the hash table, and its value would be its frequency, which right now is just 1. The next element is 5, so let's add that as well and set its frequency to 1. Next up is another 4, so we would increment its frequency to 2, and then we do the same thing with the second 5. Finally, the last element is a 6, so we'll add it to our hash table with a frequency of 1. Once we're done with that, we can look through our hash table and simply return whichever key has a value of 1, since we know that all the other keys will have a value of 2. Now, this solution works, and it does run in O of n time, but the problem is that we need to create a hash table which will contain around half as many elements as the input array, so this ends up running in O of n space. Another way we could do this is to first sort the array so that all the duplicate numbers are next to each other. Then, we could traverse the array and make sure that each pair of numbers are equal to each other. Once we come across a number that is by itself, we know that that's the number that we're looking for. This solution doesn't require any extra space, but the problem now is that the cost of sorting runs in O of n log n time. So how do we solve this? The key to solving this problem efficiently is to use bitwise operations. Specifically, we can use the Bitwise XOR operator. If you're not familiar with bitwise operations or binary digits, I would recommend you review that first. But as a refresher, Bitwise XOR will result in a 1 only if both digits are different from each other. Otherwise, the result is a 0. So for example, let's say the first number is 1100, and we're going to XOR this with 1010. The leftmost digits are both 1s, so they're the same digit. So 1 XOR 1 results in 0. Next, the first digit is a 1, but the second digit is a 0. Since they're different, 1 XOR 0 results in a 1. Similarly, the next two digits are also different from each other, so we get another 1. And lastly, 0 and 0 are the same digit, so this results in a 0. And now we've successfully performed a bitwise XOR. So why is this useful? Well, one of the nice properties of bitwise XOR is that if you XOR the same number with itself, then since each digit will also be the same, you will always end up with 0. In other words, the number cancels itself out. Another useful property is that if you XOR 0 with any number, then you will get that number as your result. For example, if we XOR all zeros with 1001, then the outer digits are different from each other, so they result in 1s, while the inner digits are the same, so they result in 0s, and we end up with the same number, 1001. So using this property, we're going to traverse the array and XOR each element with the next one, and keep a running total of the result. So we'd start with 0, and 0 XOR 6 will be 6. Then 6 XOR 6 will cancel out to 0. Then 0 XOR 7 will equal 7, and again, 7 XOR 7 cancels out to 0. Finally, 0 XOR 8 results in 8, and our final result is our answer. Now you may be asking, will this still work even if the duplicate numbers aren't next to each other? And the answer is yes, it will still work because XOR is both commutative and associative, meaning that A XOR B is equal to B XOR A, and that A XOR B then XOR C is equal to A XORed with B XOR C. This means that no matter what order the numbers are in, the numbers that appear twice will always end up canceling out to 0, and the final result will always be the single number. So now let's do a concrete example to demonstrate this in Python. Let's say that this is the nums array, and you can see that the single number is the 5 in the middle. We'll initialize our answer to 0 and XOR each number in the array with our answer, and we'll traverse the array using the variable num. So first, num will be 9, which is 1001 in binary. The bitwise XOR operator is the caret symbol, so this line here will XOR answer and num, and then assign the result to answer. So remember, any number XORed with 0 will just result in that number. So 0 XOR 9 is just 9, so we'll update answer to be 9. Next, num is 2, which is 0010. When we XOR the two digits, the result is 1011, since only the second to leftmost digits are the same, and this will be our new answer. Next, num is 5, which is 0101. This results in 1110 since only the rightmost digits are the same, and will update answer. Next up is 9, which is again 1001, and this results in 0111. And finally, num is 2, and when we XOR these two numbers, the result is 0101. But notice that 0101 is the number 5. So, as we expected, the 9s and 2s canceled out to 0, leaving only the 5 left. So now that the answer is 5, all we have to do is return answer and we're done.